Hello everyone, welcome to Learn Overflow. In this video, we will discuss about another LeetCode problem that is the longest consecutive sequence. This is a medium level LeetCode question and we will understand how we can solve this question. Moreover, we'll look into what are the thought process behind solving a question like this. We'll look ahead to multiple solutions and come up to a best case solution that we can think of at any moment. So I hope you will find this video interesting and watch till the end to understand it completely. So let's understand what this question is all about. So this question says like you're given an unsorted array. So this array we are given as nums. This is unsorted. This is not given as sorted. Okay. So return the length of the longest consecutive element sequence. Okay. Length of longest consecutive element sequence. We return that. And what it says, we must write an algorithm that runs in order of n time. Okay. So it should run in order of n time. That's great. So first, we shouldn't be worried about looking at this. Okay. First, let's try to find out a solution to this question. Let's try to understand how we can actually find a solution. Once we reach the solution, then we'll look into various ways we can reduce the time complexity to order of n. Okay, we'll ultimately do that. Now let's understand one example and see what the exact thing they are asking. What does they mean by the length of longest consecutive element? Okay, there are like 104, 200, 1, 3, and 2. Okay, these are the given, and it's just the 4 being the answer. Okay, so why is it so? The longest consecutive element sequence is like 1, 2, 3, and 4. So we can find 1, 2, 3, and 4 are there in our nums array. So the longest sequence we find is the length of the longest is like 4 is the length, and therefore its length is 4. Okay, all right. So then here on we find 0, 3, 2, 7, 2, 5, 8, 4, 6, 0, 1. So we can find 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's like 9 elements are there. So answer is 9. Okay, so look carefully. There can be multiple values, like multiple elements with the same values. Okay, it's not necessarily like the elements are unique. The elements can be repetitive as well. All right, so we can think of something. Let's understand the constraint once and then we'll just look into that. So it's constraints like num length can be 0 as well. So it may contain that the nums has nothing in it, and the it up to 10 to the power 5. Okay, and each of the element can be minus 10 to the power 9 to 10 to the power 9. Okay, no problem. Well, I will look into that. First, see, if we're given an array like this, then we need to find the longest consecutive like element sequence, then the easiest way that comes in mind is to sort the array. Okay, sort the array in ascending order, and then we'll find all the elements one after the other and keep on counting the length of the like consecutive elements till it continues, and then you will end up having the longest sequence you have, right? And just return the longest part. So that's the easiest way that comes in mind. But what's the problem with sorting the array? The biggest problem with sorting the array is that whenever we sort an array, the best case sort we can come up to is like order of n log n. We cannot go be less than that, right? We cannot come up to a solution of order of n in sorting. So once we cannot come up to an order of n solution in sorting, so at least we know that there is a solution which is just sort this array and keep on counting the consecutive element, like length of the consecutive element sequence. So there's n log n for the whole array, like n log n for every array elements, like the sorting purpose, and then you have traversing the whole array once to find the maximum length. Okay, that's like order of n. So order of n plus n log n. So that is ultimate complexity is something like order of n log n. So that's what we have over in this question. That's the first case we come up to. Now we need to reduce the complexity to order of n. So when we need to do something like that, that we need to reduce our time complexity to order of n than being or like reducing complexity. So we need to keep something in return, right? We need to consider or lost something in return. So that is more like when we are trying to reduce the time complexity, we need to increase our space complexity. So we need to increase the space complexity. That means initially we are doing our space complexity was like order of 1. Now we need to take and increase our space complexity. How we can do that? We think of say another array or uh, another some kind of collection framework so that we can traverse through it and easily find out the next elements we can go ahead with. So that's the idea, kind of like we can have a lookup table, something like that, so that we can easily figure out the next elements to the current element and whether we have a sequence or not. Okay, so that's the idea. We need to compromise with our space complexity over here. So like what we can do over here, okay, like we will use an hash set. Hash set being, why we're using a hash set? Hash set being, look, there can be repetitive numbers, right? So it's useless to just keep keeping all the numbers in array and just keep on checking whether we have that consecutive elements or not. Like say there is an array for us, like it's like if an 5 times 6 times 0, okay, if there are continuous elements are there, 5 times 6 times 0, and then there is like 1. So what's the longest consecutive element? The longest consecutive element is 2, like length of the longest. So it's useless to just keep on going through all these elements while we can actually go on through them only once, right? So just keep a hash set so that we can have a unique elements for us, and then we have the element and we'll find the answer. So that's the idea behind the hash set, like taking a hash set. And then what we can do over here, we will like go through each of the values in the hash set and then look for whether the hash set contains num plus 1 or not. Like the current value, say the current value being num, and we'll check if the hash set dot contains the num plus 1. If it the contains num plus 1, then keep on checking for the next element. So it can be like it's more, you can find out that the time complexity we can reduce it to something like order of n, right? Because once we went through the whole array, we will actually end up like going through all the elements we have. Okay, so that's the idea behind this. Now how we can do that, because just telling that it will be order of n is maybe tough for you to understand, but let's do something. Let write some code over here. Okay, write some code, and then I will again like explain you the whole code, like how it works, and then I will explain you how the particular code that we will write will be an order of n solution. Okay, so let's do that. All right, so here this particular question works in this manner. So now let's understand how we actually solve this in order of n. So first look at what we did. We created an hash set. Okay, so we had a hash set over here, and in the hash set we keep on adding all the numbers we are given in our nums array over here. Okay, so we just added all of them. The next thing we took the longest tick being our final answer, being the longest character sequence we just able to find out. Okay, so that's the longest consecutive element sequence. That's the longest sequence over there. Next, we keep on like we took like for each of the num in our hash set. Okay, for each of the num in our hash set, we just keep on checking like whether hash set that contains num minus 1. Like in case our hash set dot contains num minus 1, if that is false, so that means if our hash set doesn't contain our num minus 1, then we went ahead with the further steps. But if our hash set contains our num minus 1, that means we are already being through that number. Okay, so we just keep on traversing. So it's just nothing, it's just traversing through the nums array only once. Okay, just traversing through the nums array only once. Next is what we're doing over here. We like took two variables. That is the current number, the current number being our number for which we are calculating the next element, like the starting number of our sequence, and then the current stick being the maximum elements we end up having in our longest sequence. Okay, being a current sequence what we're continuing. That's being the one thing, just we're starting with it. Now, next we just keep on checking while has set that contains nums current number plus one. This current number being our current number we have over here. So has it contains current number plus one. That is, if it contains a consecutive element, we just keep on incrementing our current number. Being we just moved on to the next element and then increased our current stick. So see like how we can let me explain that, then I'll explain how we can say it's an order of n. Then we have a longest stick being our final answer, and then we find the maximum of our longest stick till now. There is initially 0 or whatever value, and the current stick, whichever is the maximum stick we came across, I will simply at the end of the whole array we'll simply return that. Okay, that's the whole idea. Now let's understand why we are saying it's an order of n solution. You may argue that this is an order of n for loop, and within that we are again running an while loop, and this is traversing for almost like all the elements. So isn't it order of n square? Let's understand that. Let's understand how we can say that. See, like say we have an particular array like this, say particular array like let's take this array, okay, and say there's like I'm just taking the array in a sorted format so that it becomes easier for me to explain you. Okay, since the hash set is just like hash set that contains returns us in order of one, so we can think of it in a sorted order, and then let's think of that and try to understand it. How is it working? 3, 4, then there is 100, and then there is 200. Fine. So this is the numbers we have over here. Now let's understand. First, we took num being one came across for us. Okay. Now let's understand what further we have. We're checking hs that contains num minus one. Num minus one is 0. So hs just contains that's false, and we're taking a not of that. So we are to true. So we're moving into our if part. Okay. Then we are finding a current num being 1, okay, and then current stick being 1. That's the one element we found till now. Next, we are checking while hs dot contains current num plus 1. Current num while hs dot contains current num plus 1 is like while hs dot contains 2, contains is an order of 1 like search case. It returns as a the complexity over here is order of 1. Now we went to the 2, we increased our num value being 2, and we increased our stick being total 2 elements being found till now. Moving ahead, we again keep on checking for this number, keep on checking for this number. Okay, next we like for the next number, our this 100 comes up. Okay, so hc that's why the stick breaks, and then you find the max longest stick. Okay, next we go ahead, and our num was like our num had only checked for this value, right? Our internal loop traversed through the whole this part, but our num is standing at this position, so we moved on to the next num, and then you can see the hs that contains num minus 1, right? This contains num minus 1, and we are actually not moving into the array. It's like the loop is going on, but we're not doing anything. All right, so what's the complexity is for? Nothing. Then we went to 3, num is 3, and then we find num minus 1 is also there. We went to 4, num minus is also there. It's like a just an looping condition. Just you are just stepping for that number of steps. Okay, like it's just you are giving not I equal to 0, I less than n, I plus plus. So not I plus plus, rather you are giving I plus 1, I plus 2, or I plus 3. So that's the number of steps you are giving, because it's not doing anything. It just keeps on traversing the array. Okay, just a traversal. It's not like for like 4 till 4, it is not doing anything. Then it will turn up to 100, and then it will do something. That's where again complexity comes in. So like the while loop ran from here to here, but the for loop is not running from here to here. The for loop found that there are no elements in it. Like it just shouldn't do anything in it. It just kept on just jumping these elements, and it ended up here. So it's like the part of for loop is not working. At that part, while loop is working. So it's like traversing the whole array only once. It is not like while loop will again look into these numbers. While loop will like when for loop is pointing at this element, while loop will never go through this element. So you cannot see like the repetition is going on or repetitively we are traversing through each element, right? We're traversing through the only ones. So that's the idea. We can say that it's coming up to an order of n solution. Okay. So the first solution we looked is in sorting the array and then finding the stick. But for the next solution, we find that to increase the decrease the complexity, we should increase the space complexity. Okay, so that's how we equalized our time complexity, and that's how we run our whole loop over here. So that's the main idea behind this question. That's how we solve a question like this. So I hope I can make you understand how this particular question works. Okay, so make sure to subscribe to the channel and don't forget to hit the like button. Also, if you have any doubts understanding this question, make sure to just comment your thoughts. I will be happy to help you out in the comments as well. Thank you all for watching this video. Hope to see you soon in my next video as well. Thank you.